Good afternoon. Good afternoon, everyone. I am Spot On Weather Meteorologist Matthew Euler, and welcome to my latest video. This one is going to be my latest Teleconnections Discussion update. This one I put together yesterday afternoon, but we'll go ahead and go through these and show you what's going on with the various teleconnections and how they may impact upcoming weather patterns. All right, starting with the 500 millibar height anomalies. This is from yesterday evening. Let me show you in a minute here. Okay, so what we have going on as we brief this from west to east across the northern hemisphere, a reminder that the blue and the greens represent upper level troughs, and upper level troughs are associated with cooler and unsettled weather. The orange colors and brown colors are representative of upper level ridges. And underneath upper level ridges, we typically see warm and dry weather. So just wanted to refresh you on that. And so let's go ahead and take a look at the major features that we see currently across the northern hemisphere. Across northern Siberia, we have a very deep closed upper level low in the purple colors here in the upper left-hand portion of the diagram. As we work our way now from west to east, there's an upper level trough, generally located just east of the Kamchatka Peninsula there across the Northwest Pacific. We see weak upper level ridging, generally located here across the central North Pacific Ocean. We do have an upper level trough north of this upper level ridging. So we have an upper level low and troughing above or to the north of this ridging across the Pacific Ocean. So the trough is generally centered across the Bering Sea. We do see additional ridging downstream here, right on into northwestern sections of Canada. And we do also have on the weather map an upper level trough, which was positioned just off the central California coastline. This upper level trough or lower heights is associated with a remnant tropical system. To the northeast of that, we have a very strong upper level ridge, which is parked over central Canada, extending north up to the Arctic area. Downstream of that anomalously strong upper level ridge, we do have a little bit of troughing beneath it across the central U.S., across Nebraska into Kansas. And then we see another upper level low, a closed low and troughing, generally located over eastern Canada, with ridging then downstream of the trough in eastern Canada. So we got ridging back over the North Atlantic. And then we have an upper level trough just to the west of Europe with downstream ridging across Western Europe. In fact, there was talk, I just saw this article yesterday about anomalously warm temperatures for Europe once again beneath this upper level ridge. If we look at the Madden-Julian oscillation MJO phases and areas of enhanced convection, we generally describe the MJO in phases 1 through 8. And so if you notice, phases 1 and 8 are generally associated with convection on the west and east sides of South Africa, respectively. We have MJO phases 2 and 3, where we get enhanced lifting and convection across the Indian Ocean. MJO phases 4 and 5 is convection across the maritime continent of Australia. And then we have MJO 6 and 7, which is generally associated with enhanced rising air motion and convection across the western tropical Pacific. And finally, phase 8 can also show up as enhanced rising air motion and convection in the deep tropics there at the international dateline, 180 degrees west longitude. If we look at the temperature composites here on the left, just keep in mind that blue indicates below normal temps, yellow indicates above normal temps on these composites here on the left. And again, as a reminder, these temperature composites, this one I'm showing you is for August, September, October, ASO, the abbreviation ASO for August, September, and October months. But keep in mind that this changes. These phases mean different things at different times of the year. So right now, phase 8, as an example, would be quite a mild pattern from the Gulf Coast to the Mid-Atlantic. In the wintertime, phase 8 is actually the opposite. It's much colder. So just an example there. So what's going on over here on the right-hand side, the latest model forecast for the MJO, starting with the JEFS V12. This runs from 19 September to the 3rd of October. You'll notice these yellow lines represent varying degrees within the ensemble forecasting system, various possibilities. These yellow lines represent those. So you see much of the darker lines, whether we're talking the black line, as well as this red and blue line, are all within the small inner circle here, according to JEFS V12, right on through the 3rd of October, which the smaller inner circle basically means that the MJO is weak, it's non-impactful, it's the null phase. Very little change in the weather at all for the U.S., at least attributed to the MJO. We look at the CFS V2 extended right here on the left. Very similar situation, right? We got a lot of the lines concentrated within the small inner circle on the CFS V2. Now this one goes all the way out through the 18th of October. But generally, you see some of these yellow lines are favoring, if possible, maybe some of these MJO phases may work themselves out. A couple of the ensemble members are showing MJO working its way out into phase 1 and phase 2 over time. But we'll see what happens. But really the cluster of these, the average of all these ensemble members is contained right there in the center. Over here in the middle, we have the European extended bias corrected, also showing a lot of the yellow lines. Notice the clustering of all the yellow lines here in the null phase. And then finally over here on the right, going out through the 16th of October, a very similar situation. The BOM, the Bureau of Meteorology there, Australia runs this model. You do see some of these yellow lines, potentially MJO working in a 7, 8, and 1, perhaps through the 16th of October eventually. We'll just have to wait and see what happens with this though. But bottom line here are the MJO signals are weak on all the models over the next 2 weeks, with a minimal influence for the U.S. weather. If we look at the El Nino Southern Oscillation, the ENSO update, this is the latest, this is the most recent one I could pull for the NOAA Coral Reef Watch Daily 5-kilometer SST, sea surface temperature anomalies. This was back on the 17th of September, midweek this past week, and you notice some significant things going on across the Pacific Ocean in particular. You see that we have some brighter orange colors indicating well above normal temperatures, water temperatures. We're looking at the water temperatures here. Well above normal water across just off the west coast of the United States, as well as back towards the northwestern Pacific. Generally to the east-northeast of Japan, there's a fetch of water that's well above normal, and well above normal water in the Sea of Japan itself. Also down towards Taiwan, just off the east coast of China, there's well above normal water temperatures going on. And also look across the Arctic here in the upper left-hand portion of this thing, of this graphic, well above normal waters across the Arctic waters there. And that continues all the way across north of the Bering Strait and right north of Alaska. We have above normal water temperatures in the far north. Additionally, we have above normal water temperatures generally to the northeast of Iceland, generally towards the Barents Sea. Well above normal water temperatures there as well. And that warmer than normal water actually goes into right around the British Isles, as well as into the Western Mediterranean, well above normal water temperatures. And then look at the blue colors on this sea surface temperature anomaly map. We have below normal water temperatures generally across those tropical areas, but really it looks like it's focused more so on the central equatorial Pacific for the coolest anomalies right now for the water temperatures. More of a central based look to the La Nina that is developing. We also see below normal water temperatures, a patch of that below normal water, generally to the south of Iceland and Greenland across the North Atlantic, and that's associated with the North Atlantic wormhole. Now, how does the overlying atmosphere respond in this tropical area here in that Nino 3.4 region, the tropical eastern and central Pacific? Well, we have something called the Southern Oscillation Index, SOI, and as of August, the end of last month, I'm waiting for the new update, it's at positive 0.4, the Southern Oscillation Index. That generally equates to the atmosphere behaving more like ENSO neutral conditions across the tropical eastern and central Pacific. Warmer than normal waters, we kind of talked about those. Really, the Pacific stands out. Any other things here? I mean, you really see there's not much in the way of the blue coloring on this graphic, showing much of the way of cooler waters, especially in the Pacific, North Pacific Ocean. It's very warm. We look at the El Nino Southern Oscillation intensity classifications. Keep in mind, when you see ENSO neutral, El Nino, or La Nina, NOAA is looking at the water temperature departures in this Nino 3.4 region, which has the blue, kind of like that blue square, and then the filled in with more of that peach color here in the eastern side. But you can see this rectangle, which is highlighted with the darker color. That's your Nino 3.4 region. So this is a region that NOAA really looks at as far as classifying whether we have El Nino, La Nina, or ENSO neutral. These are the strengths of the various classifications, and you see the water temperatures. If it's a weak situation, like whether it's La Nina or El Nino, it's weak. The water temperatures in this Nino 3.4 region are only going to be running 0.5 to 0.9 degrees Celsius above or below normal. If it's a moderate El Nino or La Nina, your water temperatures in Nino 3.4 are going to be running 1 to 1.4 degrees Celsius below or above normal. And then a strong El Nino or La Nina, that generally indicates the water temperatures in this Nino 3.4 region are running 1.5 to 1.9 degrees Celsius above or below normal. Now, neutral conditions, generally, how do we classify neutral? And the water temperatures in the Nino 3.4 region range from positive 0.5 Celsius to negative 0.5 degrees Celsius. That's a neutral type of situation. And notice the 3.4 Nino region is bounded by these latitudes and these longitude bucks. Now, keep in mind, you can get a case where you get a very strong situation where your water temperature anomalies are in excess of 1.9 degrees Celsius above or below normal. So that would be considered a very strong classification for El Nino or La Nina. We look at the latest ENSO forecast. Now, I just pulled this down yesterday afternoon. The IRI latest plumes are here on the left for September. And odds have definitely increased for La Nina to kick the 25-26 winter off. These odds, or the probabilities, have increased since the last release by IRI, the Columbia Climate School. Blue bars, these blue vertical bars, generally indicate La Nina forecast probability. The gray bars represent ENSO neutral forecast probability. The red bars indicate El Nino forecast probability. So you notice September, October, November, December, November, December, January, February, and January, February, March. All right, that's really what I care about right now. You notice the red bars are very short. That indicates the probability of El Nino is pretty much non-existent for the upcoming winter season. But these blue bars, you see this little axis here over here, the y-axis, this vertical axis, shows the probability of these various ENSO states ranging from 0 to 100%. So let's start off with October, November, and December. And notice this blue bar represents a La Nina probability, and it's up to 60% in October, November, and December. And then ENSO neutral is just under 40%. So you see this disparity. The blue bar is taller in the months of October, November, December, indicating we have an increased probability more so for La Nina. The same thing goes for the months of November, December, and January. Notice the blue bar is taller than this gray bar. That indicates we have a 59% chance of a La Nina in the months of November, December, January versus only a 40% for ENSO neutral conditions. And then finally, that blue bar starts really getting shorter, right? December, January, and February, we now have a 50% chance of La Nina and about a 45% chance for ENSO neutral. So the probabilities are not that far apart when we look at December, January, and February. But then when we look at January, February, and March, do you notice the gray bar is now taller than this blue vertical bar? Well, that indicates that there's a 53% chance for ENSO neutral conditions, vice only 40% for La Nina in the months of January, February, and March. All right, so you see what's going to happen here. We've increased our odds for La Nina to occur, and then we're going to look at transitioning to more of an ENSO neutral condition for the upcoming late winter months, January and February. I believe the transition, from what I'm seeing, is really going to take shape in January. We'll go from that weaker La Nina over to more of ENSO neutral. Over here on the right, these are the different model predictions for ENSO. This is released just yesterday, September 19, 2025 release from IRI. And you'll notice this maroonish darker line here represents the dynamical average of all the models. And then the solid green line represents the statistical average of the models. And so in either case, so let's just look at this green line. This green solid line represents the average of all the models, all the statistical models. It's average. And notice we get down to minus 0.5 degrees C, maybe minus 0.6 C, and then back to minus 0.5 C between the months of October and February. So we transition on the statistical models to a very weak La Nina briefly. And then on the maroon solid line, we're a little bit stronger with the La Nina. We're down to minus 0.7 degrees Celsius in the months of October, November, and December. And then we go up to about minus 0.65 C in the months of November, December, January. And then we come back to minus 0.5 C in December, January, February. And then we actually drop into neutral conditions in the months of January, February, and March. One thing of note here, I really noticed this. See where the green and the maroon solid lines intersect, right where I have my red dot. That is basically saying we are now transitioning to ENSO neutral conditions at this point, where both the average of the dynamical models and the average of the statistical models kind of overlap. So the probability is pretty high we're going to transition from a weak La Nina. Now, we said that the dynamical average went to about minus zero point 0.7 Celsius. Minus zero point 0.7 Celsius fits the weak La Nina criteria, right? 0.7 Celsius, cooler than normal waters in the Nino 3.4 region. That's right here between the values of 0.5 and 0.9. So we're looking at a weak La Nina. This doesn't look strong. There are a couple outliers that want to bring, the cooling waters in that Nino 3.4 region down to minus 1C. But those are kind of the outlier models, right? Like you see the cluster of these lines right in this zone. So the chances of these outliers actually being correct, the confidence is not so high. If we look at the probabilities based on the months here on the left column, let's just take a look at October, November, December, OND, and we have a 60% chance of La Nina developing this fall, and then only a 39% chance of neutral conditions. If we look at November, December, January, NDJ, we have a 59% chance for La Nina and only a 40% chance for ENSO neutral. But then we go to December, January, and February. Again, look at how close the La Nina probability and the ENSO neutral probability are now becoming. 50% chance of La Nina and a 46% chance for neutral. That's not far off. And then finally, look at January, February, March. There's a 40% chance of La Nina, and now there's a 55% chance for ENSO neutral conditions. So again, what I've been looking at, I would say January will be that transition month from a weak La Nina to neutral conditions. So bottom line here is odds have increased for La Nina to develop this fall, and it's not looking necessarily like a complete front end to back end winter with ENSO neutral conditions. If we look at the quasi-biennial oscillation, the latest update on the QBO, you notice this blue line here. It's basically anywhere to the left of this. This is the pressure in millibars over here. The solid gray vertical line. Anywhere left of the solid gray vertical line, we are in an easterly phase of the QBO. All right. Negative values are associated with that easterly phase of the QBO. What does this mean? That means the winds in the stratosphere above the equator are blowing from the east. If it's a positive westerly phase of the QBO, the winds in the stratosphere above the equator are going to be blowing from the west. So we have easterly winds in the stratosphere above the equator. We're expected to remain in easterly phase for the upcoming winter, 25-26 winter. And generally, a QBO in the easterly phase generally tends to favor a weaker wintertime stratospheric polar vortex, and a negative phase of the NAO. Now, I just recently was posting something like this yesterday in social media, and BAM Weather, they came back with a really great point, and I'm going to call it out. BAM Weather. They replied back to my comment about, hey, QBO, easterly QBO favors a weaker stratospheric polar vortex and a negative phase of NAO. But they did make a great point. They did mention that in a La Nina type situation, actually it favors the opposite. The easterly QBO with La Nina is a little bit different than easterly QBO with El Nino. And so in La Nina, they had mentioned back to me that, hey, that has led to positive NAO cases as most recent as I believe they put the 21-22 winter season. So again, this is just research, right? This isn't foolproof. This is just a general rule of thumb, and it's just guidance. It's not the end all be all. But I did appreciate that feedback from BAM Weather yesterday. Making that comment. So we'll just have to see what happens. But in general, the research indicates what I have right here at the bottom. Now let's look at the actual other teleconnections forecast, starting with the Arctic Oscillation. On the left here, showing you the impacts of the AO being negative. And so you see you have a much deeper trough, which allows much colder air to descend into the United States, the Midwest to the East Coast when a negative AO. You're generally warmer and drier on the U.S. West Coast. You have a very strong ridge in the Gulf of Alaska. So you got that East Pac ridge. It's stronger. It's more persistent. You got a subtropical jet with storm systems taking a more southern or equatorward track. The Aleutian low, the polar vortex, is further west. When we look over Alaska, and you're getting more of this cross-polar flow established like we saw last winter, which brought very cold air down into the U.S. right across from Siberia. So the negative AO is a very important thing to look at. And for the East Coast, a negative AO, that increases the risk for freezes in the deep south and along the Gulf Coast in winter. The polar front location is variable and further south overall. If you get a more active subtropical jet to go in combination with this colder air much further south, you can get some wintry precip. You can get some more of those East Coast storms and nor'easters in this type of pattern. Over here on the right, the opposite occurs with a positive AO. You now got a strong jet stream coming off the east coast of Asia with a positive AO. You've got more of a west to east zonal type of jet stream. So the storms generally move west to east, and you generally get more milder conditions across much of the United States. It's usually drier. The polar front is much further north, so you get these low pressure disturbances to move across the northern U.S., the Great Lakes, and New England. Further south, again, it's dry. So with a positive AO, one other thing to mention is the polar vortex is very strong, and the Arctic air tends to remain bottled up over the Arctic itself. You look at the forecast now. This is the European EPS AO 50 perturb members right on out through about the 4th of October. And so the green line represents the average of the ensembles, of all the ensemble numbers. And so let's take a look to see what's happening. So we're in a slightly negative AO right now through the 21st of September. And then we go slightly positive in the forecast from 21 to 27 September. And then we go slightly negative to neutral through the 4th of October. We look at the European EPS AO 50 perturb members. This is the 46-day forecast, which just initialized on the 18th of September. It goes all the way out in early November, the 46-day forecast for AO. Again, slightly negative right on through the 21st of September, then slightly positive from 21 to 27 September. Then we go slightly negative again from 27 September right to 8 October. So that's a pretty good stretch of time there where we can go slightly negative again with the AO according to this 46-day European EPS forecast. And then we transition, see where the green line is? It's more closer to the solid zero line here in the middle of the graph. That's more neutral conditions through early November. Looking at the NOAA JEFS V12, AO 30 perturb members, this is the 16-day forecast out to the 5th of October, showing a slightly negative AO through the 20th of September, and then slightly positive from 21 to 28 September. And then we go more towards neutral conditions for the remainder of the forecast period out to 5 October. The NAO, North Atlantic Oscillation Forecast. What's the latest on this? Look at this, negative NAO on the left. We got a huge blocking high across the North Atlantic up towards Greenland. And we have troughs on both sides, west of the strong blocking high and then east of the strong blocking high. And what this does, when you bring this high up so far to the north, you're going to have troughs on either side of that blocking high that are really going to dig deep further south into the mid latitudes. So with a negative NAO, you got more of a direct connection of air coming from the Arctic down into the eastern U.S. with a negative NAO. Same thing with Europe over here, where you get more of a northerly wind into Western Europe, and you get the Arctic air to kind of spill into England. Parts of France, Norway, Sweden, and Finland are in that as well. And beneath this blocking high over the North Atlantic, the conditions are very mild. In fact, if you get nor'easters to form in a negative NAO, the lows, the storms themselves, those nor'easters, they tend to hug the coast, the east coast more of the U.S. because they're not going to run towards the high, right? They're going to go up and over this anomalously strong blocking high. All right, so let's take a look over here on the right. This is the positive NAO. Notice with the positive NAO, we have more of a west to east jet stream. We call that zonal jet stream. It's generally situated over the northern U.S. So again, all those storm systems, these red L's, these low pressures, generally tend to follow the jet stream. The jet stream is the guide for all these little storms, and they're generally moving west to east rather quickly in this scenario with a positive NAO. Notice also now over Greenland, it's much colder. The air's Arctic origin, the solution low is much stronger across the North Atlantic. All the low pressures over the Arctic regions are usually stronger, so you have a stronger polar vortex with a positive NAO. It's generally mild across much of the U.S., specifically south of about Interstate 90 in the U.S. So let's take a look at the forecast. This is the European EPS NAO 50 per term member forecast out to 4 October. So we're starting off with a negative NAO initially through the 21st of September, and then we go neutral 21 to 23 September before we transition back to negative. Follow the solid green line here. We are fairly negative on this EPS outlook generally from 23 September right on through the 4th of October. If this were to come true, you'd have some cooler conditions along the U.S. eastern seaboard for sure. If you look at the European EPS NAO 50 per term members, 46-day forecast, this one runs out to early November. Notice we start off slightly negative on this model through the 21st of September. Then we turn negative from 21 September all the way to the 8th of October. Again, another prolonged stretch of negative NAO in this case. And then we go slightly positive to neutral conditions right on through early November, basically from the 8th of October through early November. And then the NOAA JEPS V12 NAO 30 per term member forecast. This goes out to the 5th of October, showing a slightly negative NAO on the JEPS V12 model through the 21st of September, transitioning to negative from 21 to 26 September, then neutral through the 5th of October. So this is a little bit different, right? The JEPS V12 NAO model, a little bit different. You see that the EPS is pretty bullish about the NAO going negative longer, generally from 23 21 September timeframe to about the 8th of October. Whereas the JEPS V12 is saying, yeah, it'll go negative, but it's not as long. And then the NAO becomes more neutral the rest of the way through early October. If we look at the Pacific North American, the PNA forecast, showing you on the left, this is an example of a positive PNA, and you can read what the PNA is about here and what a positive PNA does versus a negative PNA. You know, positive PNA, think below normal temperatures across the eastern U.S. You have more of a western upper level ridge with a positive PNA and a eastern trough. With a negative PNA, we flip things. We increase chances of above normal temperatures across the eastern U.S., with our region being on the western fringes of the above normal temperature area. So the negative PNA, think western trough and eastern ridge. Again, think trough, cooler temperatures, and think ridge, milder temperatures. So, and this has really played a huge role in past winters. It really has. When we see the PNA go negative for long periods of time, this is what you get in the bottom right here, this graphic. Below average temps across western U.S. and Canada, more stormy across the Pacific Northwest and western Canada. Meanwhile, over the southeastern and mid-Atlantic areas, it's dry and above normal. Let's take a look at the forecast now. The European EPS, PNA 50 per term members, and this one goes out to 4 October. Notice that we're going to be at a slightly positive PNA through the 21st of September. Then we work our way to neutral from 21 and 22 September. And then we go slightly positive again from 23 to 25 September. Before transitioning slightly negative to even closer to this neutral line. Even going slightly positive there in early October for the PNA again. European EPS, PNA 50 per term member, 46-day forecast out through early November. Notice a slightly positive PNA through the 26th of September, generally. And then you see a slightly negative PNA from 26 September to 1 October. And then you go back more strongly positive here. See how this green line comes up pretty good into the positive values there in early October. So from basically positive from 1 October to 16 October, and then it goes back towards neutral through early November. Looking at the NOAA JEFS V12 PNA 30 per term members forecast through the 5th of October. What we're looking at here is a slightly positive PNA through the 24th of September. Then it transitions down to negative, and pretty significantly negative PNA here on this model for the JEFS V12 from 24 September to 2 October, and then it goes slightly positive again. Looking at the Eastern Pacific Oscillation EPO forecast, example of a negative EPO here on the left, where we get strong Arctic highs descending out of the high north area, the Arctic area down into the central U.S. We have more of a strong upper level high, anomalous warmth beneath it across the Gulf of Alaska, and even some of this ridge extends all the way into mainland Alaska itself, resulting in milder winters in this case. Notice we have a upper low there south of the upper high. So we got a high over low situation with a negative EPO. Generally, we get low pressure or troughing to the southeast of the Hawaiian Islands. Over here on the right, the positive EPO, just different effects, right? We have now a milder lower 48. We have a much stronger Aleutian low there in the Gulf of Alaska. We got a large and persistent storm track right through the Gulf of Alaska, strong jet stream between it, and strong subtropical high pressure. So you get milder Pacific air, which pumps into the western and southern portions of Canada and locks in cold over Alaska. You generally get northeast Canada is also very cold in this situation, as well as the Davis Strait over in this location. Just again, look at the milder conditions, more of a west to east jet stream here in this case, with the more of a positive EPO. So let's take a look at the forecast. European EPS, EPO 50 per term members, right on through the 4th of October. We're heading up. We're neutral on the right on through the 24th, or actually neutral right now, and then we become pretty significantly positive with EPO. So look at this graphic on the right. Look at the weather pattern across the U.S. Milder temperatures, west to east coast. If this definitely verifies, you're looking at that possibility with EPO this strongly positive, and then it works down towards neutral on the 24th of September, but then it goes back positive again, not nearly as strong, but still positive nonetheless. Right on through the 4th of October, it remains positive, slightly positive. European EPS, EPO 50 per term member forecast out through early November. This is also showing this major rise on the positive side of the EPO, which that is going again to support this type of pattern on the right for the U.S. coming up in the next 2 weeks, if this were to verify. But yeah, let's go back to that. So very strongly positive EPO here on the 46-day EPS forecast. Then it dips down to slightly positive to neutral pretty much from the 26th of September through early November. And then finally, the NOAA JEFS V12 EPO 30 per term member forecast showing a neutral to climbing positive through the 24th of September, then slightly positive to even neutral as we get towards the end of September into early October. All right, so now let's take a look and examine the latest EPS, the European Ensemble Prediction System. Let's take a look at the latest 500 millibar height anomaly forecasts, which shows us where the troughs and the ridges are located at the middle levels of the atmosphere. When I say 500 millibars, it's another way to say that is about 18,000 feet above mean sea level. So if we take a look at what's going on here in the upper left, this is yesterday's analysis. So we had a very strong upper level ridge. This has really been a dominant feature. It started further west over Western Canada a couple of weeks ago, and now it's just slowly migrated to the east. And you see this strong anomaly. See the brown colors well above normal heights for this time of year, and a very strong ridge across central Canada extending north towards the Arctic. And then either side of this strong anomalous ridge, we have a couple other features to talk about. We have some troughing back towards the Aleutian Islands in Alaska. We have another trough on the front side of this strong ridge across portions of eastern and southeastern Canada. And then beneath it, across the United States, we see beneath the ridge directly, we do have some lower heights there across eastern Nebraska, as well as down to Kansas, indicated by the blue colors. We also see some troughing extending down off the coast of New England. And then we have some weak troughing across southern Georgia. And then there's also some of that weak troughing off the coast of California. And again, that was in association with a dissipating tropical storm, the tropical system. Over here on the right, upper right, we're now showing you the 72-hour forecast for the EPS. You see this green color indicating well below normal heights associated with a stronger upper closed low here and troughing just south of Alaska mainland. Extending the trough axis is extending southwest. We have ridging beneath that across the Pacific. We have another trough just kind of lingering there, weak closed low off of the California coast. We do see some of the trough extending into western Canada. And then we do see that upper level ridge. It is starting to weaken a little bit. It's not nearly as strong, but it still is there, an upper level ridge in 72 hours. This is for Monday, by the way. This is early Monday morning, the 22nd of September. And then we see a trough downstream of this upper level ridge over Canada. We see a little weak troughing over the northern Minnesota, northern Wisconsin area. Weak troughing there over eastern Kansas, eastern Oklahoma, as well as parts of western Arkansas, Missouri. And then we do see some weak troughing off the U.S. East Coast as well. And then you notice this other very strong, this green color here, this very strong closed upper low, generally situated just to the south of Greenland. The bottom left here, we're showing you the forecast now for the 25th of September, right down here at the bottom left, 144-hour outlook. Let's see what's changed. Well, the upper low there, just west off the west coast of Alaska, that is weakened, but we still have some troughing and a closed low there. We do see some ridging. The ridge is flattened some compared to the initial starting point in the upper left. The bottom left here, we're showing the ridging is now oriented more southwest to northeast, that ridge axis on up into Hudson Bay, southern Hudson Bay. We have another upper level ridge there extending along between Canada Maritimes and the west coast of Greenland. We do have weak troughing that is situated down in southern Missouri and Arkansas. This is not quite closed off yet as a closed upper low, but over time it does close off, and it does eventually translate towards the Ohio Valley and the southern Missouri Valley, Tennessee Valley as well, where there could be some very high rain rates associated with this troughing out ahead of it with more southerly flow of the winds. So we'll keep an eye on that one. You do see there is a pretty strong closed low still situated to the southeast of Greenland at this point, so it shifted slightly east by the 25th of September. And over here in the bottom right, we're looking at higher than normal heights. We have ridging building into the Aleutians of Alaska. We have troughing over the Arctic Ocean north of Alaska and then extending down towards the mainland of Alaska. We have a deeper trough and lower than normal heights approaching the western Canada coastline, as well as just remaining off the west coast of the United States. And then we do see some above normal heights and some weak ridging across Wyoming and Montana up into south central Canada. And then further downstream from that, we got this weaker troughing across the Tennessee Valley down into Arkansas, Mississippi, and Alabama. And finally, we have some troughing situated there, still continuing to maintain its position southeast of Greenland at that point in time. This is for the 28th of September, so this would be next Sunday. So my final thoughts on today's video, after we just took a look at all of that, the MGO is in the null phase. And so I expect minimal influence on United States weather right on through early October. So the next 10 to 14 days, the MGO does not look very strong. And so therefore will not be very influential in the sensible weather across the United States. We still are in the ENSO neutral conditions, okay? But I will say the CDAS data is showing a significantly below normal water temperature anomaly in ENSO 3.4 region. And so I would expect once we meet the time criteria that we will go from ENSO neutral to a weak La Nina type situation here in the fall. So we do see ENSO neutral conditions. Again, the atmospheric response, that's a little bit old. That was as of the end of August. I'll wait to see what the new monthly SOI is after, hopefully in the next week or so. But we are seeing those below average sea surface temperatures for sure across the ENSO 3.4 region. The sea surface temperature anomalies elsewhere, we are seeing warmer than normal water across the North Pacific, and it's very, very strongly warm, well above normal warmer water, specifically around Japan and off the U.S. West Coast. We also see warmer than normal waters across the Mediterranean. We see cooler than normal waters located across the equatorial tropical Pacific, including south of Hawaii and over the North Atlantic. There's that little patch of cooler than normal water that's associated with the North Atlantic wormhole. Models are indicating a slightly negative to slightly positive AO phase through early October. The negative phase would favor cooler than average temps across the eastern U.S. If we were to transition to the neutral phase, that would favor near average temperatures in a more zonal west to east jet stream with weaker, faster moving high and low pressure systems moving west to east. And with a positive phase of this AO, that generally tends to favor above average temps across the eastern U.S. Models are indicating a range from slightly negative to neutral NAO right on through early October. A negative phase of the NAO favors cooler than average temps across the eastern U.S., as well as across Western Europe. And there's different types of these negative NAOs. There's east-based and there's a west-based negative NAO. And really where that block sets up across the North Atlantic, it really makes a difference on who's more impacted, the eastern seaboard of the United States or Western Europe. It's really interesting to watch it. But anyway, we have a blocking ridge with a negative NAO over the Northwest Atlantic. The neutral phase of the NAO favors near average temps across the eastern U.S. and a lack of upper level blocking. The models are indicating a slightly positive to slightly negative Pacific North American pattern of PNA through early October. Positive PNA is going to favor below normal heights and troughing and cooler than average temps over the eastern U.S. If we get a negative PNA, that favors above normal heights and upper level ridging and warmer temps over the eastern U.S. Models are indicating a positive Eastern Pacific Oscillation EPO through 24 September. Then neutral conditions. Positive EPO is going to favor an upper level trough across Alaska and the Bering Sea area with a downstream ridge and warmer than average temps from the northern plains to the U.S. East Coast. Neutral EPO, on the other hand, favors near average temperatures for the eastern U.S. And then models are indicating, I didn't show this, I don't have any, I looked at the site yesterday, but really didn't have any updates since the 8th of September, so hopefully the site's okay, and we'll have an update soon. But from what I'm seeing otherwise, the models are indicating a strengthening stratospheric polar vortex through early October, with increasing zonal mean zonal winds and a cooling stratospheric temperatures. And that's what we expect this time of year, a strengthening polar vortex in the stratosphere as the latitudinal temperature gradient continues to increase between the poles and lower latitudes. So we're starting to increase, we're getting a larger temperature difference across latitude lines as we head further and further into fall. And my overall assessment, based on everything we see here, with the teleconnections being slightly negative, ranging slightly negative to slightly positive for the AO. We're seeing a slightly negative to neutral NAO in the forecast, a slightly positive to slightly negative PNA, and null MJO phases. You put that all together, and it favors anywhere from slightly above to perhaps slightly below temperatures across the eastern U.S. I'm not talking major heat waves. I'm not talking unusually like double-digit type chill. Nothing like that. And so neutral conditions are still in place, but they will definitely are on their way to transitioning to a weak La Nina. And the IRI plumes, the latest ones, indicating mainly neutral. And so forecast. Now this has changed. I need to update this, and I failed to update this. Actually, this is all different now. This was based on my last video. So now we're looking at the IRI plumes showing a transition to La Nina, and the La Nina will continue from mid-fall right to January, and then we go to ENSO neutral conditions in January. So with near neutral teleconnections and minimal influence on the Pacific side from the MJO over the next 2 weeks, we expect very little change in the overall weather pattern for the eastern U.S. And what I mean by that is, we're not going to see any crazy deep troughs or really highly amplified ridges over the U.S. These teleconnections would promote more of a west to east jet stream. And so you're still going to get weather systems. You're still going to get cold fronts that are going to move west to east. But we're not looking at anything significant. Now, one thing that could kind of put a little wrench in our plan here based on these teleconnections would be any tropical activity if it comes up and off the East Coast and it's a fairly decent strength, or recurring typhoons out in the Western Pacific. You use the Bering Sea rule. You got recurring strong typhoons in the Western Pacific that kind of go east of Japan and then up towards transition to extratropical storms as they head towards Alaska and the Northeast Pacific. That could be a game changer of the pattern, and some of these teleconnections could flip around a little bit more significantly. So tropical activity, we always watch this time of year to see how it kind of plays in with the long wave pattern, the global winds from Asia to the U.S., from the U.S. all the way over to Europe. How are things going to change? We'll keep an eye on things, but that's all I got for now, everybody. Hope you enjoyed this video. Again, I'm trying to get back to this on a weekly basis. I'm trying, but sometimes things come up, and I'm unable to get this done every single week. But hopefully you enjoyed the video, and I certainly enjoy presenting the material and kind of like taking a look at these global patterns, these upper ridges and troughs and how they all connect from Asia all the way across the Pacific towards the U.S. and then even on the other side, Atlantic side, all the way over to Europe. We live on one planet in which everything is connected. So what happens in Asia is going to have downstream impacts in the Pacific, and that's going to have downstream impacts on us in the United States. All right, that's all I got for now, everybody. I've got one more video that is ready to roll. I'm going to try to get to that here within the next couple days. I took a look at for the next video, I took a look at going back to 1981. I went back to look at the below normal temperatures in August and September, back-to-back months, August, September, below normal temperatures, and what happened the following winters. And by the way, little sneak peek for you for the next video, I have a new winter analog. I do have a new winter analog after analyzing, just using a couple of the teleconnections in addition to ENSO conditions, in addition to just taking into account we have below normal temperatures in August and September across the Mid-Atlantic. What does that mean for the winter in the Mid-Atlantic? Well, I'll share that with you soon. All right, that's all I got for now, everybody. Until next time, take care and God bless everyone.